All right, we're going to start looking at horizontal asymptotes, which is your end behavior, and figuring out how we can find that algebraically. Okay, so the way you guys can find horizontal asymptotes is by determining the end behavior. And the way you guys can find end behavior is you can compare the degree of the numerator and the degree of the denominator. And just a reminder, degree is your highest exponent in the numerator and in the denominator. So here's the situation we're going to look at. If our numerator, the degree in the numerator, is less than the degree in the denominator. Okay. If this case happens, then there is a horizontal asymptote at y equals 0. Okay. So let's just talk about how this happens. So here's our example, 1 over x. My degree in my numerator is 0. Okay. Because really I could rewrite this as x to the 0 over x to the first. Anything to the 0 power is 1, and then we just write that as x. Okay, so this is a degree of 0, and then this is a degree of 1. So my numerator degree is less than, smaller than my denominator degree. In this case, there's a horizontal asymptote at y equals 0, which tells me that my limit as you go to positive or negative infinity will approach that horizontal asymptote of 0. So here's my limit. That's one thing. One way you can remember it is your degree is in the numerator smaller than the degree in the denominator. The other thing you guys could do is you could graph this function. If you graph 1 over x, it looks like this. And so as x goes to infinity, you will see that we're approaching 0. And as x goes to negative infinity, you will also see it approaches 0. The other way you guys could think about this is if you take infinity and you were to plug it in for x, okay? You can think about it as 1 over infinity. If I take 1 divided by a very, very, very large number, what does it become? If you're not sure, you can always use your calculator and try it, okay? 1 divided by, this is saying 1 times 10 to the negative 7. So it'd be point and then 6 zeros and then the number 1. That is really, really close to 0. Okay, so that's what's happening to it. If you take 1 divided by a very, very, very large number, in this case it's infinity, we're going to get close to 0. So that's the other way you can think about it. Same thing here. If we're going to negative infinity, we would just be approaching 0 from the bottom side, so the negative side. So that is 0. Here's another example. Okay, we have 1 over x squared. My degree in my numerator is 0. And the degree in my denominator, in this case, is 2. So we still fit under this classification. And so if I were to think about this one, you could graph it. If I graph this one, looks like this. So as you approach, look to the right and look to the left, you should see it's going to 0. The other thing is, once again, you could think about 1 over infinity squared. That's an extremely large number. I mean, infinity is the biggest number, and then if you square it, it's just going to make it even bigger. So 1 divided by an extremely large number would approach 0. Okay. Same thing with negative infinity. That would approach 0. Okay. So in general, the rule is where C is any real number and R is any positive rational number. Okay. This is true. If you're going to positive or negative infinity and C is a constant, so you have some number over an x to some power, it will equal 0. Okay. So if I have the limit as x approaches positive or negative infinity of 2 over x to the 10th, we know that will equal 0. That's an example of that. Here's another one. Limit as x approaches positive or negative infinity, negative 3 over x to the 3rd. That will also approach 0. Okay, so that's of that form. So that is how you guys can find your horizontal asymptotes when your numerator is smaller than your denominator.